Hi everyone, welcome to Pinnacle Education. Today we're going through Edexcel International GCSE, May 2024, Further Pure Mathematics, Paper 1. Question number 1. In triangle ABC, side AB is equal to 2x centimeters, BC is 3x centimeters, and AC is 4x centimeters. Let's draw the triangle first to see what's happening. So we have triangle ABC with side AB is 2x centimeters, BC is 3x centimeters, and AC is 4x centimeters. The area of triangle ABC is 50 cm squared. So area is provided 50 cm squared. Find to two decimal places the value of x. So how can we link the sides with this area? We have one equation, the area equation, which is half AB sine C. This can be equated to 50. And if we interpret these letters A, B, and capital C is the angle that we choose. It's going to be one of the angles in the triangle. And A and B would be the sides, the adjacent sides of this angle that we choose. So let's choose angle ABC as the angle. And its adjacent sides would be 2x and 3x. So we need this angle. We need the angle value to substitute into the area formula so that this equation works. So we don't know what the angle is. We need to calculate the angle first. Is there anything else we can use to calculate the angle by using the sides? Yes, we can. With cosine rule, if we know the three sides of a triangle, we can find any angle that we want. So let's try and calculate the angle ABC using cosine rule. So we'll say cos angle ABC is equal to, it goes like this. So it is going to be the square of one of the adjacent sides, so 2x the whole squared, plus the square of the other adjacent side, 3x the whole squared, minus the opposite side squared. So 4x is the opposite side of the angle that we're looking at. So 4x the whole squared, and all of this divided by 2 times the adjacent side 2x times the adjacent side 3x. This is the cosine rule formula, and from here we can calculate the angle ABC. So this becomes angle ABC equals cos inverse. We'll move cos to the other side, the cos function to the other side. So it becomes cos inverse function. And then let's simplify the expression on the other side. So 2x the whole squared would be 4x squared. 3x the whole squared would be 9x squared. Minus 4x the whole squared would be 16x squared. And all of this will be divided by the numbers. If we multiply the numbers 2, 2, and 3, 2 times 2 is 4, 4 times 3 is 12. So 12, and if you multiply x and x, that becomes x squared, so 12x squared. Let's continue simplifying this. So cos inverse of, so 4 plus 9 is 13. 13 minus 16 is minus 3. So the numerator becomes minus 3x squared. The denominator is 12x squared. And if we simplify that further, this becomes minus 3 over 12 is minus 1 over 4. X squared and x squared will cancel. So only minus 1 over 4 remains. We can actually calculate this and get the angle. So cos inverse of minus 1 over 4 is 104.4775 and so on degrees. The question wants the final answer to be written to two decimal places. So it's good that we have more than two decimal places for intermediate values so that there is no rounding error. Anyway, so we have found the angle ABC and we know the two adjacent sides, 2x and 3x. Now we can substitute all of this into the area formula, half AB sine C equals 50. Let's do that. So half times, one of the adjacent sides is 2x times, that is A. B is the other adjacent side, which is 3x times sine C. So capital C is the included angle that we just calculated, angle ABC, that is 104.4775 and so on. So half AB sine C is equal to 50. From here we can see that the only unknown left in this equation is x, and we can calculate x, and that's what we are asked. We are asked to find the value of x to 2 decimal places. Let's do that. We can simplify the left-hand side. The 2's cancel. What remains is 3x squared sine 104.4775 equals 50. And we can move everything else to the other side so that x becomes 50 over 3 sine 104.4775. And all of this will be under a square root. This gives us 4.148 centimeters. And we can round this to 2 decimal places, 4.15 centimeters. And this is the answer for number 1. Okay, question number 2. f of x is equal to 2x squared plus 4x plus 9. This is a quadratic function. Given that f of x can be written in the form, okay, this form is a completed square form where a, b, and c are integers. Question A, find the value of a, the value of b, and the value of c. So for question A, we have to find the completed square form. So f of x is equal to 2x squared plus 4x plus 9. And to complete the square, we will only be looking at the first 2 terms, the x squared term and the x term. First of all, we need to make sure that the coefficient of x squared is 1. So we will factor out 2 from the first 2 terms. So if we factor out 2, what remains is x squared plus 2x in the first 2 terms, and the last term remains 9. Now, at this stage, we can start completing the square of the terms inside the bracket. So it becomes 2 bracket. We'll use another bracket inside. So x squared becomes x plus 2x will become plus 2 divided by 2, which is plus 1. Close the bracket, the whole squared minus this value squared. And we have plus 9 outside the bracket. This is how we complete the square. So now we can multiply this 2 into the bracket. 2 will multiply with the bracket, the square bracket, and 2 will also multiply with this. Minus 1 squared is just going to be minus 1. So 2 times minus 1 is minus 2. Let's do this. So we will get 2 times x plus 1 the whole squared minus 2. And then outside the big bracket, we have plus 9. So finally, we have 2x plus 1 the whole squared minus 2 plus 9 is plus 7. And we found the completed square form where a is 2, b is 1, and c is 7. So we can say a is 2, b is 1, and c is 7. That is question A. Now question B, hence or otherwise find, number 1, the value of x for which 1 over f of x is a maximum. 1 over f of x. So let's think about f of x first. If we look at the f of x function, the x squared has a positive coefficient, meaning it's going to be a u-shaped parabola. If it is a u-shaped parabola, it'll have a minimum point, and we can find the coordinates of this minimum point, or we can also call it the vertex. We can find the coordinates of the vertex by using the completed square form. So our completed square form is 2 times x plus 1 the whole squared plus 7. The minimum point would be, so x coordinate of the minimum point is negative of this value. So negative of plus 1 is minus 1. The y coordinate of the minimum point is this value, 7. So that's the minimum point of f of x. So let's say this is f of x and this is the minimum point. It occurs when x is equal to minus 1 and y equals 7. Let's also think of some points beside the minimum point. So So the vertex is -1, 7. What if x is equal to 0? When x is equal to 0, what happens? So if we replace 0 in place of x, y value would be 2 times 1, which is 2, plus 7. Y value would be 9. And because of symmetry, we can also expect the same on the other side of the minimum point. When x is equal to -2, y value will also be 9. And we can expect higher, larger values when x is equal to 3, when x is equal to 1, and when x is equal to -3. The y values are just going to get larger. So -1, 7 is the minimum point. But what about 1 over f of x? So let me draw a table for x, f of x, and 1 over f of x. So we can see that when x is equal to -3, -2, -1, 0, 1. When x is equal to -1, f of x is 7. When x is equal to -2, f of x is 9. When x is equal to 0, f of x is 9. When x is equal to -3 or 1, f of x values are larger. So I'll just say larger for now, just to make you understand. We don't need to write exact values here. So what happens to 1 over f of x values when x is equal to -1? 1 over f of x would just be 1 over 7. So 1 over 7. When x is equal to -2 and 0, 1 over f of x value would be 1 over 9 and 1 over 9. So if we compare 1 over 7 with 1 over 9, 1 over 7 is larger. It's a bigger number than 1 over 9. The larger the denominator, the smaller the number. So what's really happening as you go further away from -1 in terms of x, 1 over f of x values, they become smaller, opposite to f of x. So when x is equal to 1, 1 over f of x would be smaller. When x is equal to -3, 1 over f of x would be smaller as well. So we can see that the maximum value of 1 over f of x occurs when x is equal to -1, which is opposite to f of x. And that's what we have to write here. So question number 1, find the value of x, for which 1 over f of x is a maximum. So we can say 1 over f of x. Therefore, 1 over f of x is a max when x equals -1. This is question B1. Now question B2, let's have a look. Find the maximum value of 1 over f of x. So we already have it. The maximum value of 1 over f of x is 1 over 7. The maximum value of 1 over f of x is 1 over 7. That's it. That is question 2. Question 3. A. Show that summation of 5r minus 3, where r goes from 1 to n, is equal to n over 2 times 5n minus 1. So let's start writing the summation formula. Summation of 5r minus 3, where r goes from 1 to n. So if we really think about this, the first term will be when we replace r with 1 in this expression. So the first term is 5 times 1 minus 3. This is the first term. Plus, the second term would be 5 times 2 minus 3. Second term. Let's find the third term as well. Third term would be 5 times 3 minus 3. And this pattern will continue until we reach 5 times n minus 3. So what do we really get? So 5 times 1 minus 3 is 2. That's the first term. Second term, 5 times 2 is 10. 10 minus 3 is 7. Second term is 7. The third term, 5 times 3 is 15. 15 minus 3 is 12. That's the third term. And this will continue till the last term, which is 5n minus 3. So what is this? What type of series is this? When we compare the terms, we can see that the terms progress by adding plus 5. So adding 5 each term represents that this is an arithmetic progression with a common difference 5. Arithmetic series where the first term is 2, the common difference is 5. And we want to find, the summation formula really wants to find the sum to the first n terms. So we need to find the Sn formula. The formula of Sn is n over 2 times a plus the last term L, or there's another form, n over 2 times 2a plus n minus 1 d. Because we already have the expression for the last term, we can just go ahead with the first formula. So we can say Sn is equal to n by 2 times the a value is 2 plus the last term is 5n minus 3. And let's simplify this. This is n over 2 times 2 minus 3 is minus 1, so it becomes 5n minus 1. And this is what they want. N over 2 times 5n minus 1, and we can say this is the summation. This is the same as the summation formula. So summation of 5r minus 3, where r goes from 1 to n. We have shown. Question B. Hence or otherwise evaluate the summation of the same function where r goes from 31 to 60. So B, summation of 5r minus 3, r goes from 31 to 60. There could be many ways of solving this. One of the ways is that we subtract. So we have the summation of 5r minus 3 from r equals 1 to 60. So this has 60 terms, the first 60 terms of this series. And from this, we will subtract the first 30 terms, where r goes from 1 to 30. And if we do this, we will have the last 30 terms of the series as requested. So we have the formula to solve this. We can use the formula that we calculated earlier. Let's use the formula n by 2 times 5n minus 1. So the first one, since n is 60, it's going to be 60 over 2 times 5 times 60 minus 3. And then the second summation would be 30 over 2, n value is 30 here, 30 over 2, 5 times 30 minus 3. And let's solve these. 8, 9, 1, 0. The other one, where n is 30, gives us 2205. And when we solve this, the summation is 6705. So let me rewrite this. So summation of 5r minus 3, where r goes from the 31st term to the 60th term, is 6705. I just checked with the mark scheme, and I've made one mistake. So when we apply the formula, we should be using this, n over 2 times 5n minus 1. And I have subtracted 3 by mistake. I should have subtracted by 1. Sorry, this should be minus 1. This is minus 1, this is minus 1. And when I redo this, when n is equal to 60, the summation is 8970. When n is equal to 30, the summation is 2235. And the final answer, 8970 minus 2235, gives me 6735, and this is the correct answer. Okay, question C. Given that the summation of 5r minus 3, where r goes from 1 to n, is 3783, find the value of n. So we don't know what n is, but the summation is 3783. So we can use the formula. So summation of 5r minus 3, where r goes from 1 to n, is 3783. Yes. And then this can be solved by using the formula that we found, n over 2, 5n minus 1. So the summation formula can be replaced with n over 2, 5n minus 1. And this is equal to 3783. We can move 2 to the other side, and we can multiply n into the bracket. So if I multiply n into the bracket, it becomes 5n squared minus n. And when we multiply 2 with 3783, that gives us 7566. That means we have a quadratic equation, 5n squared minus n minus 7, 5, 6, 6 equals 0. So this does not look like an easy factorization. So what can we do? How many marks are given for this? For question C, we're given 3 marks. It doesn't look like we need to show how to use the quadratic formula to solve this. This could be done by simple factorization. So we can use our calculator to solve this, but we will only use the calculator to check what factors can we split this equation into. So we know that when we factorize this quadratic expression, we'll get 2 brackets, and one bracket would have 5n, the other bracket would have n. One would have a positive sign, the other would have a negative sign, but it'll be difficult to find out the factors of 7, 5, 6, 6. To quickly check the factors of quadratic expression, we can use our calculator. So we will press mode on our calculator and press 5 for equation. And then we can choose number 3, which is the quadratic equation. So we'll press 3. And then for A, B, and C, we'll be writing the coefficients of n squared for A, the coefficient of n for B, and the constant term for C. So we can see our coefficient for n squared is 5, so we'll press 5. And then to store this value, we will press equal sign, and it has been stored. For B, our coefficient is -1, so we'll press -1, and we'll store this value. And for the constant term, our value is -7, 5, 6, 6, and we'll press equal sign. And we'll press equal sign again to solve. And this shows that the first number is 39, the first solution. So we'll just note this down, that the first number, x1, is 39, just on the side. And then to get the next number, to get the next solution, we'll press equal sign again. And the second solution is -194/5. So we'll note that down, -194/5. So now we can back calculate these values. Think about it. If x1 is equal to 39, we can say x minus 39 is equal to 0. And same goes for the other solution. If x2 is equal to -194/5, we can move 5 to the other side, and this would be 5x2. And then we can move -194 to the other side. This will be 5x plus 194 equals 0. So these will be our 2 factors. So this is how we can use our calculator to figure out the factors if factorization becomes difficult. So now we will go ahead with these factors. The first factor is going to be 5n plus 194. The second factor will be n minus 39. And then I'll just erase this. You should also erase that, just in case. It's not needed anymore. And then we will solve this. So we will say, therefore, n is equal to -194/5, or n is equal to 39. So 2 answers for n. So let's look at the context of the question. Find the value of n. N cannot be negative, n cannot be a fraction. So we will reject the first answer. We will go ahead with n equals 39. So this is our answer. This is rejected. Okay, that's number 3. Let's look at question number 4. The surface area of a sphere with radius r centimeters is increasing at a constant rate of 50 pi centimeters squared per second. Let's just note this value down. Let's just say this is dA by dt, and it is 50 pi cm squared per second. And do we know the formula for surface area of a sphere? Surface area of a sphere is 4 pi r squared. So we have a sphere. If we know the radius, we can calculate the surface area, 4 pi r squared. This area is increasing at a constant rate. The question says, find in centimeter cube the exact volume of the sphere at the instant when the rate of increase of r is 5/12 cm per second. So when the rate of increase of r, dr over dt, is 5 over 12 centimeters per second. At that point, we need to find what the volume is. So how do we find volume? Volume formula for sphere is 4 over 3 pi r cubed. So to find the volume, we only need to know the radius. And we need to know the radius at a point when dr by dt is 5 over 12 cm per second. And we already know dA by dt is a constant value of 50 pi cm squared per second. How can we link these two rates of change so that we can find the value of r that we want to calculate the value of volume? So we have dA dt, dr dt. There must be another derivative with a and r. So since we have the formula for a in terms of r, we can find dA by dr. So we just need to differentiate 4 pi r squared. When we do that, 2 will be moved to the front. So 2 times 4 is 8 pi r. That is dA by dr. And how do we link these three derivatives? We can using chain rule. So let's make dA by dr the subject. And we can see dA is in the numerator. So the second derivative, dA over dt, can be placed like this, so that dA is still in the numerator, and dt needs to be cancelled somehow. So it needs to be multiplied with dr by dt, but that won't cancel dt. We'll have to multiply with the inverse of dr, the reciprocal of dr by dt, which is dt by dr. And if we do that, yes, dt's will cancel, and finally we have dA over dr, which makes sense. Now let's just write down the values of dA by dr. It is 8 pi r. dA by dt is 50 pi times. dt by dr would be the reciprocal of 5 over 12, which is 12 over 5. And from here, we can find the r value that we need. So r will be 50 pi times 12 divided by 8 pi times 5. We can see the pi cancel, and we have 50 times 12 divided by 8 times 5. This gives us 15. So for this to happen, radius will be 15. And we can find the exact volume when this happens. So therefore, volume is 4 over 3 pi. In place of r, we're going to substitute 15 cubed. 4 over 3 pi r cubed. Let's calculate this. So we'll only multiply 4 over 3 with 15 cubed. So the number is 4500, and we have the pi. And volume, since it's volume, the unit will be centimeters cubed. 4,500 pi cm cubed is the answer. Question 5. A particle P is moving along the x-axis at time t seconds, where t is positive, or it could be 0. The acceleration a meters per second squared of P is given by this formula. So let's just imagine what's happening. So we have point P moving along the x-axis, and the acceleration of this movement is given by 3t minus 4. Okay, when time is equal to 0, P is at rest. For P, we know what acceleration is. It's 3t minus 4. It'll vary depending on time. And we also know when time is equal to 0, the velocity or the speed will be 0 because it says P is at rest. So we'll say V is 0. Question A. Find the velocity of P when t is 4. So when t is 4 seconds, what is v? That's what we want to find. How can we find the velocity? We can only find velocity if we have an expression or equation or formula of velocity. From the acceleration formula, we can calculate the velocity formula. If we think about acceleration, it is the same as dv over dt. Acceleration tells us how much velocity changes per unit time. So since we know dv over dt is 3t minus 4, to find v, we have to integrate dv over dt with respect to t. Therefore, this will be integral of 3t minus 4 with respect to t. And let's integrate this. So 3t, when we integrate this, it becomes 3t squared over 2. When we integrate minus 4, it becomes minus 4t. And we'll have a constant c. To find the constant, we can use these values. When t is equal to 0, v is equal to 0. So we can say when t equals 0 and v equals 0, 0, in place of v we can substitute 0. 0 is equal to, in place of t, if we substitute 0, this will be 0 minus 0 plus c. So c is also equal to 0. That means our velocity formula is 3 over 2t squared minus 4t. And then, now we can calculate when t is equal to 4, v is equal to 3 over 2 times 4 squared minus 4 times 4. And this gives us 8. 8. What's the unit? Let's have a look. So the unit for acceleration is meters per second squared. The unit for velocity would be meters per second. So 8 meters per second. That's the answer for A. Question B. At time capital T seconds, where capital T is greater than 0, P is instantaneously at rest. So there's another point in time where P comes to rest, meaning velocity becomes 0, and we need to find this time value. So we can say when time is equal to capital T, v is 0. Therefore, we'll use the velocity formula. So velocity is 0, and this is equal to 3 over 2 capital T squared minus 4 times capital T. And this shows that we can factor out capital T. So when we factor out capital T, from both the terms, we are left with 3 over 2t minus 4. That is equal to 0, and this is true only when t is equal to 0 or 3 over 2t is equal to 4. And this shows that t could be 4 times 2 divided by 3, which is 8 over 3 seconds. Since capital T is greater than 0, t will be 8 over 3 seconds. We reject this. That is question B. Let's look at question C. When t is equal to 0, P is at the point with coordinates -10, 0. So that's a position. And that's a position of point P when time is equal to 0. And since it's moving along the x-axis, we can see that the displacement is -10. The x value is -10. We'll only be looking at the x value. We don't need to look at the y value. So when time is equal to 0, let's use x for displacement. So x is -10 when time is equal to 0. So using that, find the displacement of P from the origin when time is equal to 3. So let's write down what we know. Question C, when time equals 0, x is equal to -10. When time is equal to 3, what is x equal to? This is what we want to find. So again, we'll have to integrate velocity because v is equal to change in displacement over change in time. So since we want to calculate x, since we want to find a formula for x, we'll have to integrate dx over dt, or we have to integrate v in a way. The velocity formula is, it is 3 over 2 t squared minus 4t. So integral of 3 over 2 t squared minus 4t with respect to t to find the formula for displacement. Now let's integrate this. So t squared becomes t cubed, and we'll have to divide it by 3. Okay, I'll just write down. So 1 over 3 times 3 over 2 times t cubed minus 4t squared. We'll have to divide by 2 plus another constant d. So if we simplify this, we will have half t cubed minus 2t squared plus constant d. We have a reference value We have a reference point when t is equal to 0, x is equal to minus 10. Let's use that. So when t equals 0, x equals minus 10, therefore minus 10 is equal to 0 minus 0 plus d. If we substitute 0 in place of t, we get 0. If we substitute 0 in place of t here as well, we get 0. That's why it's 0 minus 0 plus d. And d gives us minus 10. Therefore, the final formula for x is half t cubed minus 2t squared minus 10. And now we can use t equals 3. When t equals 3, x is equal to half times 3 cubed minus 2 times 3 squared minus 10. And this gives us negative 14.5. Or in fractions, negative 29 over 2. In decimals, this is negative 14.5 meters from the origin. And that's the end of question 5. Question number 6. The line L passes through the point A with coordinates negative 2, 2, and the point B with coordinates 3, 12. So we can think of a line that passes through A and B. And then we have point C with coordinates P, Q, which lies on L such that, so there's point C on the same line, L, and it lies such that AC to CB is 3 to 2. So AC, so if this is C, the length AC is 3 parts, the length CB is 2 parts. Question A, find the value of P and the value of Q. So we need to find the coordinates of C. So let me redraw this again. So let's write down the coordinates, negative 2, 2 for A. This is question A. For B, it is 3, 12. 3, 12. And then for C, this is P, Q. We need to calculate P and Q. So going from A to B, if we look at the ratio, we have to go 5 units to go from A to B, altogether 5 units. To go from A to C, we have to travel 3 units. To go from C to B, we have to travel 2 units. So let's use this ratio in this way to calculate P and Q. So let me draw a line. Actually, I'll draw a rectangle and I'll divide this into 5 parts. So 1, 2, 3, 4, 5. So I have this rectangle and I've divided this into 5 parts. Let's say at the start of this rectangle, I'm at point A, and at the end of this rectangle, I'll be at point B, and at 3/5 of this rectangle, I'll be at point C. So I'll write down the coordinates of A. So x coordinate of A is minus 2. Y coordinate of A is 2. So I'm writing the x coordinates on top of the rectangle, y coordinates at the bottom of the rectangle. Same for the coordinates of B. X is 3, y is 12. So to go from minus 2 to 3, we need to move 5. The difference between the x coordinates is 5. So we can see that 1 unit corresponds to 1 for x coordinates, meaning at this point, my x coordinate would be minus 1. Here it'll be 0. There it'll be 1 and 2 and 3. So you can see x coordinates increase by 1 every unit. And if I look at the difference between the y coordinates, the difference is 10, meaning that y coordinates increase by 2 with every unit. So y coordinate will be 4 here, 6, 8, 10, and 12. So we can clearly see by the time it reaches point C, the coordinates are 1, 8. So with this method, we can say the coordinates of C is equal to 1, 8. That is question A. Question B, the line K is perpendicular to L and passes through the point C. Show that the equation of line K is this. So we have line K that is perpendicular to line L. So this is line L. Let me use a different color for line K. So this is K and this is perpendicular to line L. We need to write down the equation of line K. This is a straight line. To write down the equation of a straight line, we need 2 things. what do we need? We need a point that lies on the line. It is this point, c equals 1, 8. We know this. This lies on the line, and we will also need the gradient. So if we can calculate the gradient of line L, we can also figure out the gradient of line K. So let's start by calculating the gradient of line L. So gradient of line L is y2 minus y1 over x2 minus x1. Therefore, I'll take point B as my second point, point A as my first point. So y2 is 12, y1 is 2. So 12 minus 2 over x2 minus x1. x2 is 3, x1 is minus 2. So 3 minus 2. That gives me 10 over 3 plus 2, which is 5, 10 over 5, and that is 2. That's the gradient of line L. Since line K is perpendicular to L, we can say gradient of K is the negative reciprocal of gradient of line L. So gradient of line K is negative 1 over 2. Therefore, we can write down the equation of line K. So equation of K is such that y minus y1 equals m times x minus x1. The point C lies on line K, so that's our x1, y1 in this case. And gradient is negative 1 over 2. So y minus, in place of y1, we'll substitute 8. In place of m, we'll substitute negative 1 over 2. And in place of x1, we'll substitute 1. And we need to write it in this form. We'll have to move all the terms to one side where we have positive y and x. So we can move this 2 to this side. So that 2 multiplies with y minus 8. So it becomes 2y minus 16. We will multiply minus 1 into the bracket. So it becomes minus x plus 1. And we'll move all the terms to one side. So 2y plus x minus 16 minus 1 will be minus 17 equal to 0. And that's the equation of K, line K. 2y plus x minus 17 equals 0. Now, question C. The line K crosses the x-axis at the point D. Find the exact length of CD. So, okay, on the diagram, I can just add the axes. So let's say this is the x-axis. And if we extend this line K line, it intersects with the x-axis, and this point is D. So this will be something, 0. So what's the question? We need to find the exact length of CD. How can we do this? First, we'll have to find the coordinates of D, and then we can find the length. So at x-axis for line K, we can set y to be 0. Therefore, 2 times 0 plus x minus 17 is equal to 0, and x gives us 17. That means point D is 17, 0. These are the coordinates of D, and we know the coordinates of C. C is 1, 8. Yes, and then to calculate the length CD, let CD is equal to square root. We can use the length formula, x2 minus x1 the whole squared plus y2 minus y1 the whole squared. We can set any point C or D to be our point number 1 and point number 2. So let's go with point D is our point number 2, point C is our point number 1. That means 17 minus 1 the whole squared plus 0 minus 8 the whole squared. This gives us 8 root 5. Yeah, that's the answer, 8 root 5 units. So this was question C. Now question D. Question D, the point X with coordinates m, n lies on L such that area of triangle DXC is 80 units squared. Given that m is greater than 0, find the value of m and the value of n. So basically we have to find the coordinates of point X. Point X lies on line L. So let me just choose a random point. So I'll choose a random point on line L here, and I'll call this point X. Let's say this is point X. So that will have the triangle DXC. So X has coordinates m, n. M has to be greater than 0. And we can see that this triangle that we just formed is a right triangle. And we already know the length CD. Length CD is 8 root 5. We can find the base. Let's use the area to calculate the base. So area of triangle DXC is 80 square units. And how can we calculate the area of triangle? We can use the formula half times base times height, and this is equal to 80. We know what height is, we just need to calculate the base. So we can say half times base times height is 8 root 5 equals 80. So B would be 80 times 2 over 8 root 5. And this gives us 4 root 5. So basically, when we look at the diagram again, B is the length CX. The length CX is the base. So we can say, therefore, CX is equal to 4 root 5. And we can use the distance formula, since we know C is 1, 8 and X is M, N. X also lies on the equation L. So to visualize, I'll draw the line again. So we have line L, and we have point C, we have point X, and we know the distance between C and X. The distance is 4 root 5. That means we can use the distance formula to figure out the coordinates of X. So we can say distance CX is equal to square root of x2 minus x1 the whole squared. So we can say m minus 1 the whole squared plus y2 minus y1 the whole squared. So that would be n minus 8 the whole squared. And this distance is already found, which is 4 root 5. So in this equation, we can see there are two unknowns, m and n. So we cannot solve two unknowns using just one equation. We need to find another link between the coordinates of x and the line. And we already have the link. We know the gradient of line L is 2. Gradient of line L is equal to 2. And we can use points C and X to calculate the gradient of line L. So we can say y2 minus y1, which is n minus 8, over x2 minus x1, which is m minus 1. This should be equal to a gradient of 2. And then we can rearrange the equation. We can move m minus 1 to the other side. N minus 8 is equal to 2 times m minus 1, which is 2m minus 2. And then we can make n the subject of the equation. So n is equal to 2m. If we move minus 8 to the other side, it becomes plus 8. So plus 8 minus 2 becomes plus 6. So n equals 2m plus 6. This is an equation we can use to substitute in the distance equation, in the distance formula. So when we look at the distance formula, we should square both sides to get rid of the square root sign. So let's square so that this becomes n minus 1 the whole squared plus. And simultaneously, I will be replacing n with 2m plus 6. So that will be 2m plus 6 minus 8 the whole squared. And on the other side, again, we have to square 4 root 5. So if we square 4 root 5, 4 squared is 16. If we square root 5, it'll just be 5. So 16 times 5, which is going to be 80. Let's do it step by step. In the next step, we'll expand the bracket. So m minus 1 the whole squared. When we expand it, it becomes m squared minus 2m plus 1. And the second bracket, we need to simplify first. So 2m, 6 minus 8 gives us minus 2, the whole squared, equals 80. So in the next step, m squared minus 2m plus 1. We don't need the brackets anymore. So and plus, if we expand this bracket, 2m minus 2, so 2m the whole squared would be 4m squared. The middle term would be 2 times minus 2, which is minus 4. Minus 4 times 2 is minus 8, minus 8m. And then the last term would be minus 2 the whole squared, which is plus 4. And we'll bring 80 to this side, so minus 80 is equal to 0. Let's simplify this equation. So m squared plus 4m squared is 5m squared. Minus 2m minus 8m is minus 10m, plus 1 plus 4, that is plus 5. And then minus 80, 5 minus 80 is minus 75. So minus 75, this is equal to 0. We can divide all these terms by 5, so that it becomes m squared minus 2m minus 15 equals 0. Now we can factorize, and we'll get two brackets. The first terms are going to be m in both the brackets. Because of the signs we see here, one bracket is going to be positive, the other is going to be negative. We need to think of factors of 15, which will add up to become minus 2. We can think of 5 times 3, so 3 and 5. And we need minus 2 when we add them up. 5 could be minus 5, 3 could be positive 3. So that when we add minus 5 and 3, we get minus 2. So the brackets will be m plus 3 and m minus 5 equals 0. We can check this. So m times m is m squared, that is correct. 3 times minus 5 is minus 15, that is also correct, the last term. Now for the middle term, 3 times m gives us 3m, minus 5 times m gives us minus 5m, and the result is minus 2m, that is correct as well. That means m is equal to minus 3 or m is equal to 5. We have two answers for m. We should check the conditions for m. It was mentioned that m should be positive. Yes, given that m is positive, it's greater than 0, so we'll have to reject the negative answer. So m equals minus 3 would be rejected. So this is rejected. M equals 5 is the answer. So once we have the value of m, we can find the value of n using this equation. Therefore, n is equal to 2 times 5 plus 6. 2 times 5 is 10, 10 plus 6, 16. So n is 16. Therefore, the coordinates of x are 5, 16. M is 5, n is 16. Okay, question 7. Figure 1 shows a sketch of part of the curve C with the equation y equals x squared over 4 minus 3 root x plus 8. The point P lies on C and has coordinates 4, a. And question A says, show that this y coordinate A is equal to 6. So on the graph, there's point P and the coordinates of point P, 4, a. So the x coordinate is 4, the y coordinate is a. We'll just substitute 4 into this equation to get the a value. So we'll say, for question A, when x is equal to 4 and y is equal to a, the equation becomes a equals 4 squared over 4 minus 3 times root 4 plus 8. So a equals 4 squared is 16, 16 divided by 4 is 4, minus 3 times root 4 is 2, 3 times 2 is 6, plus 8. So a is equal to 4 minus 6 is minus 2, minus 2 plus 8 is 6. So a is equal to 6. Therefore, point P has coordinates 4, 6. Question B. The line capital L is normal to C at point P. Show that the equation of line L is this. So there is a straight line L that passes through point P, and it is perpendicular to the gradient of the curve at this point. So we can draw a straight line passing through. So this is a normal line to the curve at point P. To find the equation of this line, line L, we need to know a point that lies on it, which we already know. It is 4, 6. We also need to know the gradient of this line L. So if we can find the gradient of the curve at point P, we can find the gradient of line L. So for question B, we need to find the gradient of the curve. So we have the function y equals x squared over 4 minus 3x to the power half plus 8. So this is the function. The gradient function would be dy by dx. So we'll have to differentiate this. So x squared would be, we can send 2 in front. So 2 times 1 over 4 is half. and then it'll be x to the power 2 minus 1, which is just 1. And then for the next term, we can send half in front, so it'll be minus 3 over 2, but then we'll have to subtract 1 from half, so that it becomes minus half. And then when we differentiate plus 8, it just becomes 0. So that's the gradient function. What is the gradient at point P? If we want to know, we can use the x-coordinate of point P, which is 4. At this point, the gradient is half times 4 minus 3 over 2 times 4 to the power minus half. And let's calculate this. This gives us 5 over 4. That's the gradient of the curve at point P. So the gradient of line L would be negative reciprocal of this value. Therefore, gradient of line L is a negative reciprocal of 5 by 4. That means it'll be negative 4 over 5. So equation of line L would be y minus y1 equals m times x minus x1. So the point that lies on it is P. So it becomes y minus, in place of y1, we'll substitute 6 equals, the gradient is negative 4 over 5, x minus x1. x1 is the x-coordinate of point P, so x minus 4. And then let's simplify this equation. We can move 5 to the left-hand side, so 5y minus 5 times 6 is 30 is equal to, we'll multiply minus 4 into the bracket, minus 4x plus 16. And then we'll move all the terms to one side, so 5y plus 4x minus 30 minus 16 would be minus 46. Minus 46 equals 0, and this is the equation of line L. Let's have a look. 5y plus 4x minus 46 equals 0. That's correct. That is B. Now let's move on to C. So question C, the finite region R is bounded by the curve, the line L, the x-axis, and the line with the equation x equals 1. So we already have curve C, line L, and the x-axis. There's another line, x equals 1. So x equals 1 will be a vertical line where x is 1. So let's draw this. So this is x equals 1 line. And we are looking for the region bounded by this line, the curve, the x-axis, and line L. So we're looking for this region R. And we need to calculate the area. Question C says, use calculus to find the exact area of R. Yeah, so we have to calculate the area of this region. And when we look at this region, we can divide this region into two parts. The first region, let's call that R1. The second region, let's call it R2. So R1 falls under the curve, R2 falls under the line. R2 can easily be calculated using geometry. So how can we do that? We can see R2 is a triangle. So we need to find the base and the height. Height, we already know. Height of this triangle, R2, is equal to the y-coordinate of point P, which is 6. So height is 6. We need to find the base. To find the base, we need the x-intercept of line L. Let's find the x-intercept of line L first. So line L, x-intercept. This happens when we set y to be 0. Therefore, it becomes 5 times 0 plus 4x minus 46 equals 0. So 5 times 0 is 0, 4x equals 46, x equals 46 divided by 4, which is 11.5. That means we can find the area of triangle R2. Area of triangle R2, or region R2, is half times base times height. So half times, the base is 11. Oh, we need to check what base is. So let's have a look at the graph again. So the x-intercept of line L is 11.5. That means the base is 11.5 minus 4. That's the base length of the triangle. And the height is 6. So base is 11.5 minus 4. The height is 6. Let's calculate this. Area R2. This gives us 45 over 2, which is equal to 22.5 units squared. That's area R2. Next, we need to find the area under the curve within the limits x equals 1 and x equals 4. So area R1 To calculate area R1, we need to integrate the curve equation. So area R1 is equal to integral of the curve with respect to x within the limits x equals 1 and x equals 4. So let's write down the equation of the curve. So the equation of the curve is this: x squared over 4 minus 3x to the power half plus 8. And we'll integrate this with respect to, plus 8 only. Plus 8. And we'll integrate this with respect to x. Let's check again. Yes, that's right. So we will use square brackets. So let's integrate x squared. When we integrate x squared, the power becomes 3. And we'll divide the term by 3. We already have 4 here in the denominator. So 3 times 4 is 12. So it'll be x to the power 3 over 12. Minus, here x to the power half becomes x to the power 3 over 2. And we'll have to divide with 3 over 2, which means we have to multiply with 2 over 3. So let me just write down 2 over 3 times, we already have 3 here, times x to the power 3 over 2. This is the second term plus 8 becomes 8x. And that's it. Well, these are the limits, 4 and 1. And then let's simplify this. So it becomes x cubed over 12 minus 2x to the power 3 over 2 plus 8x. Now let's apply the limits. So the first bracket would be 4 cubed over 12 minus 2 times 4 to the power 3 over 2 plus 8 times 4, and subtract. Let's substitute 1 now. So 1 cubed over 12 minus 2 times 1 to the power 3 over 2 plus 8 times 1. And let's calculate these values. So the first bracket gives us 64 over 3. The second bracket gives us 73 over 12. And when we calculate this, 64 over 3 minus 73 over 12, we get 61 over 4, which is 15.25 units squared. This is the area of region R1. That means area of region R is equal to R1 plus R2. R1 is 15.25, R2 is 22.5. And when we add them, we get 37.75 units squared. That's number 7. Okay, let's look at question 8. Okay, the sum of the first and second terms of a geometric series G is 400. And the sum of the second and third terms of G, the same G, is 100. Question A, show that the common ratio of G is 1 over 4. So we need to find the common ratio R. So the first sentence says the first term plus the second term. In geometric series, the first term is A, the second term would be A times R. A plus AR, and when we add them, we should get 400, according to the first sentence. And the next sentence says the sum of the second and third terms. So second term is AR, the third term would be AR squared. To get the third term, for example, U3 would be AR to the power n minus 1, which is 3 minus 1, which is AR squared. So adding the second term and third term gives us 100. Question A, we have to find the common ratio. So we need to find R from these two equations. Yes, we have two equations and two unknowns. We can solve this. So from the second equation, if we factor out R, we can get an expression similar to the first equation. Okay, let's just factor out R. So when we factor out R from this equation, what remains is A plus AR, and yes, that is equal to 100. We already have a value for A plus AR. A plus AR equals 400, and we can substitute this equation 1 into equation 2. So we can say substituting equation 1 into 2 gives us R times 400 equals 100. That means r is equal to 100 over 400, which is 1 over 4. That's how we get r to be 1 over 4. That is question A. Question B. Show that the first term of g is 320. Now we can calculate the a value. So we can use the first equation, equation 1. If we use equation 1, a plus a times 1 over 4 is equal to 400. And then if we add a plus 1 over 4a, we'll get 5 over 4a. That is equal to 400. That means a is equal to 400 times 4 over 5. And let's calculate this. This gives us 320. So 320 is the first term of this series. Yes, we found 320. Next, question C. Find the sum to infinity of g. So sum to infinity has this formula, a over 1 minus r. And sum to infinity can only be found for progressions where modulus of r is less than 1. And yes, we have our r value that is less than 1, which makes the terms progressively smaller. So let's substitute the values. A is 320. 1 minus r would be 1 minus 1 over 4. And when we calculate this, we will get 1280 over 3. Do we need an exact value? We're not told anything about the number, significant figures, decimal places, or anything. So we have the fraction answer. We might as well write down the decimal answer. It gives us 426.6, and this 6 is recurring. So I'll just write an answer this way. The fraction answer is good enough, but this is also fine. That is sum to infinity. Now, actually, when I think about it, since it's sum to infinity, we should have our answer in an exact value form. So it's better to just leave the answer as fraction. And I've checked that with the mark scheme as well. The answer is 1280 over 3. That is question C. Now, let's move on to question D. The sum to n terms of g is Sn. Question D. Find using logarithms, the least value of n such that sum to n terms exceeds 426.6. Sn needs to be greater than 426.6, and we need to find the least value of n that does that. So let's think about the Sn formula. Sn formula is the first term a times 1 minus r to the power n divided by 1 minus r. So since a is 320 and r is 1 over 4, Sn formula looks like this. And this needs to be greater than 426.6. So let's write these down. So we can say, therefore, 320 times 1 minus 1 over 4 to the power n divided by 1 minus 1 over 4 gives us 3 over 4. This should be greater than 426.6. Now we can move 3 over 4 to the other side. We can move 320 to the other side. These are positive values, so nothing, we don't need to worry about the sign. That means what remains is 1 minus 1 over 4 to the power n greater than 426.6 times 3 over 4 divided by 320. And then we can swap the positions of minus 1 over 4 to the power n and this like that. So it becomes 1 minus, if we solve 426.6 times 3 over 4 divided by 320, it gives us 6399 over 6400. So 6399 over 6400. This has been moved to the left-hand side, and on the right-hand side we'll have 1 over 4 to the power n. So we can rearrange this inequality. We can just say 1 over 4 to the power n is less than 1 minus 6399 over 6400 gives us 1 over 6400. And we can just take logs on both sides. Log of 1 over 4 to the power n is less than log of 1 over 6400. We can use the power rule. We can move n to the front. So n times log 1 over 4 is less than log 1 over 6400. Now, to send log 1 over 4 to the other side, we need to check the value of log 1 over 4 first. So let's check this on our calculator to see whether it's a negative value or not. It is a negative value. It is negative 0.602, etc. That means whenever we divide or multiply with a negative sign in inequalities, we have to manually flip the inequality sign. That means n is greater than log 1 over 6400 divided by log 1 over 4. And let's solve this to see what we get. So log 1 over 6400 divided by log 1 over 4 gives us 6.32, etc. That means the smallest n value, the least n value that we need so that Sn exceeds 426.6 would be 7. So least n value would be 7 because n has to be an integer. The smallest n integer would be 7. And that's it. Question number 9. A. Find the value of a such that log base a, 8, is equal to 3 over 4. Log base a, 8, is equal to 3 over 4. We need to change this log form to exponent form. So in the exponent form, a would be the base, 3 over 4 would be the exponent, and 8 would be the value of that. So it'll be a to the power 3 over 4 is equal to 8. From here, to solve for a, we can take a power of 4 over 3 on both sides of the equation. So it becomes a to the power 3 over 4. On top of this, there's another power 4 over 3. We'll do the same on the right-hand side. We'll take a power of 4 over 3. So that the left-hand side becomes 3 over 4 times 4 over 3. The power becomes 1. So a to the power 1 is equal to 8 to the power 4 over 3. We can calculate this. This gives us 16. A is equal to 16. That is question A. Question B. Show that 3x log base 2x minus 4 log base 16, 8, plus 6x log base 4, 8, minus log base 2 x is equal to log base 2, 8x to the power 3x minus 1. So we need to make the left-hand side become right-hand side. So if we look at the right-hand side, the base is 2, and within the function we have 8x to the power 3x minus 1. So let's start with the left-hand side, and our first goal would be to make the base become 2 for all of these terms. Okay, so this becomes 3x log base 2x minus 4 log base 16, 8 plus 6x log base 4, 8 minus log base 2x. Let's continue this. So let's group the log base 2 terms together. So 3x log base 2x minus log base 2x. And then we have this term minus 4 log base 16, 8. So we'll apply the change of base rule with a base of 2, so that this becomes 4 times log base 2, 8 divided by log base 2, 16. So we've applied the change of base rule here. Now we'll do the same for this term. So it becomes plus 6x. The base will be 2 log base 2, 8 divided by log base 2, 4. Let's just write down 3x times log base 2x minus log base 2x. Let's see what happens when we simplify the last two terms. So if we look at log base 2, 16, the value would be 4 because 2 to the power 4 is equal to 16. So the denominator becomes 4. It is 4 log base 2, 8 over 4 plus 6x times, if we look at the denominator here, log base 2, 4, the value of this would be 2 because 2 to the power 2 is equal to 4. So this becomes log base 2, 8 over 2. We're not simplifying the numerators, the log base 2, 8, because there is 8 within the brackets of the log in the right hand side, so we don't want to change it, so we'll just keep it as 8 for now, and let's see what we can do next. So this becomes 3x log base 2x minus log base 2x. Now here we have 4 divided by 4, they're going to cancel, so minus log base 2 8 plus 6x divided by 2 is 3x, and then we're left with log base 2 8. What do we see now? We can see that in the first two terms, log base 2x is the common term. We can see that in the first two terms, log base 2x is common, and in the last two terms, log base 2 8 is common. So we'll factor these out and see what happens. So from the first two terms, we'll take out log base 2x. What remains is 3x here, and then what remains there is minus 1. Then from the last two terms, we will factor out log base 2 8. What remains in this term is minus 1. What remains in this term is plus 3x. So minus 1 plus 3x is actually 3x minus 1. Let me just rewrite this as 3x minus 1. 3x minus 1. Now when we look at this line, we have two terms overall, and again we have the bracket that is common in both the terms, the bracket 3x minus 1, so we can factor this bracket out of these two terms, so that we have 3x minus 1. What remains is log base 2x plus log base 2 8. Now we can apply the multiplication rule of logs, so that log base 2x and log base 2 8, when you add them, you just need to multiply x and 8 within the brackets of log, so that this becomes 3x minus 1 times log base 2 8 times x, 8x. And then finally, we will use the power law of logs, so that we can move 3x minus 1, the coefficient of log, to become the power, so that this becomes log base 2 8x to the power 3x minus 1. And this is exactly what right hand side is. So right hand side is log base 2 8x to the power 3x minus 1, and we have achieved it. This is RHS. Okay, question C. Hence solve the equation, this left hand side terms equal to 0. So let's write down question C. So the left hand side terms are going to be 3x log base 2x, 3x log base 2x. Let's just write these down. Minus 4 log 16 8 minus 4 log 16 base 16 8 plus 6x log base 4 8 plus 6x log base 4 8, and then the last one is minus log base 2x. Minus log base 2x is equal to 0. So equating the left hand side to 0 is the same as equating the right hand side to 0. So therefore we can just change this to log base 2 8x to the power 3x minus 1 equals 0. Then what can we do from here? We can move 3x minus 1, the exponent, to the coefficient position, so that this becomes 3x minus 1 bracket, and then multiply to log base 2 8x equals 0. From here we can individually equate these two terms, 3x minus 1 and log base 2 8x, with 0. So we can say 3x minus 1 is equal to 0, or log base 2 8x is equal to 0. We can do this because these are two different functions of x multiplied to each other and equated to 0. And whenever we have this, we can individually equate the functions with 0. So if we continue, this is x equals 1 over 3, or what happens here? So when we change the log form to exponent form, we'll take the base 2, we'll apply the power 0, which is on the other side, and that should be equal to 8x. So if we continue solving this, 2 to the power 0 is 1. So 1 is equal to 8x. That means x is equal to 1 over 8. So we get two values of x. X is equal to 1 over 3 or x is equal to 1 over 8. These are the answers of x when we solve the equation that's given in C. And that's it. That is number 9. Okay, let's look at question 10. The curve C has the equation y equals ax minus 5 over b minus x, where a and b are integers and x cannot be equal to b, because if x is equal to b, the denominator will become 0, which is undefined. So x is not equal to b. One intersection of C, this curve C, with the coordinate axes is the point with coordinates 5 over 4, comma 0. Since the y-coordinate is 0, this is the x-intercept. And we are also told that the asymptote parallel to the y-axis has equation x equals 3. So we know one asymptote equation. This is x equals 3. This is a vertical line. Question A, find the value of A and the value of B. Okay, question A. Let me just draw a quick sketch of what we know. So we have an asymptote at x equals 3. So 3. And we are told that the curve passes through the point. The x-intercept is 5 over 4, which is 1.25, comma 0. So 5 over 4 is somewhere here. The curve passes through this point. Okay, we don't know the horizontal asymptote yet. So if we look at the equation y equals ax minus 5 over b minus x, we can clearly say b is 3 because x cannot be 3. Because x is the asymptote equation, b has to be 3. So that the equation is y equals ax minus 5 over 3 minus x, so that if we substitute 3 in place of x, the curve becomes undefined and x cannot be equal to 3. That's why we choose the b value to be 3. Next, we also know the intercept. The intercept is 5 over 4, comma 0. So if we use that, we can find the a value. So let's say using 5 over 4, comma 0, the equation becomes, in place of y, we substitute 0 equals a times x becomes 5 over 4 minus 5 divided by 3 minus 5 over 4. So let's move 3 minus 5 over 4 to the other side, and it'll just be 0 because the denominator here will multiply with 0 and it is just 0. That means we have 0 equals 5 by 4a minus 5. Next, we can move minus 5 to the other side, so 5 is equal to 5 over 4a, and a is equal to, we can move 5 over 4 to the other side, so it becomes 4 over 5, and we have 5 on the other side. So this becomes a equals 4, because the 5's cancel. So we get a is equal to 4, and b is equal to 3. Okay, these are our answers for A and B. Next, question B, sketch the curve C, showing clearly the asymptotes with the equations and the coordinates of the points of intersection with the coordinate axes, so basically the intercepts. If we look at the final equation, it is y equals ax minus 5, so a is 4, 4x minus 5 over b minus x, which is 3 minus x. This is a reciprocal function, and we know how they look. They could look something like this, or they could look like this. We can only figure out the exact shape once we figure out all the asymptotes and all the intercepts. Let's do that. So let me write down the equation again. The equation is y equals 4x minus 5 over 3 minus x. So the first asymptote is x equals 3, vertical line, so x cannot be equal to 3. Okay, Let's find the second asymptote, the horizontal asymptote. For that, we need to make x the subject of the equation. So let's move 3 minus x to the other side. So 3y minus xy is equal to 4x minus 5. I'm doing this to find the horizontal asymptote. So I will group all the x terms together. So 3y plus 5 is equal to 4x plus xy. And I'll factor out x from these two terms so that this is 4 plus y remaining. On this side, we have 3y plus 5. Now, if I make x the subject of the equation, it becomes 3y plus 5 over 4 plus y. And this shows that y value cannot be minus 4. Y cannot be minus 4 because in this equation, if y is minus 4, the denominator will become 0 and the function becomes undefined. So we have found our two asymptotes. The vertical asymptote is x equals 3 line, and the horizontal asymptote is y equals minus 4 line. So we've found the asymptotes, we need to find the intercepts now. So we have one intercept, x-intercept is 5 over 4 comma 0, which is 1.25 comma 0, same thing. Let's find the y-intercept. So for y-intercept, what needs to be done? X needs to be 0. Let's use the original equation. Y equals 4x minus 5 becomes 4 times 0 minus 5 over 3 minus 0. So this gives us y equals minus 5 over 3. And this is the y-coordinate of the y-intercept. Therefore, the y-intercept is 0, comma, minus 5 over 3, which is the same as 0, comma, minus 1.66 recurring. So now we have some idea how it could look. Start the axes first. So y-axis, x-axis. Let's start with the asymptotes. So x equals 3 and y equals minus 4. The units for y, let's write down the units for y, 2, 4, 6, and so on. Underneath, minus 2, minus 4, minus 6, and so on. Sorry, this is 8. And then we can draw the units on the x-axis. So let's say this is minus 1, it's minus 2, minus 3, and so on. On the right-hand side, we have 1, 2, 3, and 4, equally spaced. Okay, once we have the units, we can draw the asymptote lines. Let me use red color for asymptotes. So the vertical asymptote is x equals 3. And then the horizontal asymptote is y equals minus 4. Let's label these. X equals 3, y equals minus 4. Next, so we're done with the asymptotes. Let's figure out where the intercepts are. X-intercept is at 1.25 comma 0. So where would 1.25 be? It would be somewhere around here. That's the first intercept, 1.25 comma 0. And then the next intercept would be at y-intercept, which is 0 comma negative 1.6. 0 comma negative 1.6 is roughly here. If I have to draw a curve through these two intercepts, I get some idea how the curve would look like. The curves will be in the second quadrant, in this quadrant here, and the other curve would be in the fourth quadrant. So let's try and sketch. This decreases and approaches the asymptote, and in this direction it increases and approaches the vertical asymptote. You need to make sure the curve is smooth, something like that. And then it would be something similar in this quadrant. I should have taken more space to draw the sketch, but this should work. It shows all the intercepts, shows all the asymptotes. It's good enough. I need to label the y-intercept. So the y-intercept is 0 comma negative 1.6 recurring. That is question B. Now question C. The straight line L with equation 4y minus 7x equals k has no points of intersection with C. So there's a straight line and it does not intersect with the curve C. And we know the equation of the line. So let me write down line L. So line L has the equation 4y minus 7x equals k. Line L is 4y minus 7x equals k. And the question is, show using algebra that the range of possible values of k can be written as m less than k less than n, where m and n are integers to be found. So basically, when we look at this equation, we have to find the range of k, range of values of k. So let's try and understand what k really means in this context. So this is line L, which is a straight line, and we understand straight lines when we convert them into y equals mx plus c form. So let's isolate y. So 4y is equal to 7x plus k, and y is equal to 7 over 4x plus 1 over 4k. Basically, 1 over 4k is the y-intercept of this line. And we've also figured out the gradient of this line. The gradient of line L is 7 over 4. So let's think about the situation using the sketch we drew earlier. So we can expect this curve to go like this towards a negative infinity, and like this towards the positive infinity in the x direction. So this is what we expect to happen. I should have used a bigger space for this sketch so that we can easily see what's happening. But now the thing is, we need to fit this straight line in this sketch. We don't have to draw the sketch of the straight line, but we have to figure out where would the straight line lie if it does not intersect with a curve. So if I draw the line like this, I can see that it intersects with a curve. But we need to draw the lines so that it does not intersect with the curve. So the line could be anywhere in this region. And the line has a fixed gradient. The gradient is 7 over 4. That's why I'm not changing the gradient of those green lines. The gradient will be fixed, 7 over 4. But what can be changed is the y-intercepts. The y-intercepts can change. There could be a range of different y-intercepts. So what should be the minimum and the maximum y-intercept values? So I can imagine that if this line with gradient m equals 7 over 4 just touches the curve here, this line would give me the maximum y-intercept value. And this line would also be a tangent to the curve because it just touches the curve at one point. So I need to find this line, the y-intercept of this line, and I also need the y-intercept of this line, which is tangent to the curve on this side. So we need the tangents to the curves. The tangent needs to have the same gradient as the curve. So basically we need to find the points on the curve where the gradient is equal to 7 over 4. And that's where our lines will intersect with the curve. So curve C has the equation y equals 4x minus 5 over 3 minus x. We need to find the dy by dx. We can use the quotient rule. The quotient rule states v times du by dx minus u times dv by dx over v squared. This is the quotient rule, and let's apply it. Our u is 4x minus 5. So du by dx would be 4. Our v is 3 minus x. So dv by dx would be minus 1. Therefore, let's rewrite the dy by dx. v is 3 minus x times du by dx, which is 4, minus u, which is 4x minus 5, times dv by dx, which is minus 1. Everything divided by v squared, 3 minus x, the whole squared. Let's simplify the numerator. 4 times 3 is 12 minus 4x. And if we multiply this minus sign into the bracket, this minus 1 becomes plus 1 and becomes plus bracket 4x minus 5. And we can just remove the bracket. It's 4x minus 5 divided by 3 minus x the whole squared. And this becomes minus 4x plus 4x, they cancel. 12 minus 5 is 7. We get 7 over 3 minus x the whole squared. This is the dy by dx value. And we want to find the points on the curve where the gradient is the same as the gradient of the line, which is 7 over 4. So gradient of C, where it matches the gradient of line L, it needs to be 7 over 4. Therefore, what are the x values where the gradient gives us 7 over 4, and this results in 3 minus x the whole squared equals 4. We can square root the other side, so 3 minus x equals plus or minus 2. And this results in 3. So it's like 3 minus x is equal to 2, or 3 minus x is equal to minus 2. That means x is equal to 3 minus 2, or x is equal to 3 plus 2. So x is equal to 1, or x is equal to 5. So there are two such points on the curve, as we expected, where the gradient of the curve is equal to 7 over 4. And those points are where x is equal to 1 and x is equal to 5. So it happens at x equals 1 and x equals 5. My sketch is not accurate. I'm just sketching this to understand what's happening. So our first line has an intersection with a curve where x is equal to 1. So we need to find the y coordinate of the point. So if the intersection happens at x equals 1, we need to find the corresponding y value. On the other side, the tangent and the curve intersect at x equals 5, and we need to find the corresponding y value. So let's do that. What are the corresponding values of y? When x is equal to 1, what is y? So we can use the curve equation. The curve equation is y equals 4x minus 5 over 3 minus x. So 4 times 1 minus 5 over 3 minus 1. So y gives us 4 minus 5 over 2, which is minus half. So the first intersection happens at 1 comma negative half. The second one, when x equals 5, what is the y value? Y would be 4 times 5 minus 5 divided by 3 minus 5. So 20 minus 5 over minus 2, and 15 over minus 2 is minus 7.5. Therefore, the second intersection point is 5 comma negative 7.5. So let me draw a quick sketch again so that we understand what's happening. So we have the two curves, one like this, the other going something like that. And we know the intersection points of the tangent with these curves. So these tangents have the same gradient of 7 over 4. We also know the points of intersection. The first one is 1 comma negative 0.5. The other one is 5 comma negative 7.5. So what are we really looking for? We're looking for lines with gradient 7 over 4, and we're looking for the y-intercept. Or maybe we're just looking for the equations of these lines. Let me name them. So this is line P, and this is line Q. So for line P, let's find the equation of the line. We can use the quick method y minus y1 equals m times x minus x1. So it's y minus 0.5, which is plus 0.5, is equal to gradient 7 over 4 times x minus 1. So let's see what we get. Y is equal to 7 over 4x minus 7 over 4 minus 0.5. And this results in y equals 7 over 4x minus 9 over 4. That's our line P. Let's do the same for line Q. So line Q, we can do the same. So y minus y1. y1 is minus 7.5. So this becomes y plus 7.5 equals m value is the same, 7 over 4 times x minus x1 is 5. So y equals 7 over 4x minus 5 times 7 over 4 gives us minus 35 by 4, and we have minus 7.5. And this simplifies to y equals 7 over 4x minus 35 by 4 minus 7.5 gives us minus 65 by 4. So these are our two equations, which are tangents to these curves. And these tangent lines have the gradient 7 over 4. And we want to find the possible values of k. And our straight line equation was y equals 7 over 4x plus 1 over 4k. So y equals 7 over 4x plus 1 over 4k. This was our equation. To find the values, the maximum and minimum values of k, we can see that 1 over 4k is the same as negative 9 by 4 for line P. And on the other hand, 1 over 4k is equal to negative 65 by 4 for line Q. So k is equal to negative 9. On this side, k is equal to negative 65. And these are the maximum and minimum values. So k lies between negative 65 and negative 9. That's the answer. So that's the end of the Edexcel IGCSE Further Pure Mathematics Paper 1 walkthrough for May 2024. Remember, success in these exams comes from clear understanding and consistent practice, not shortcuts. If you found this video helpful, please like and subscribe so you don't miss future walkthroughs. Keep practicing, and I'll see you in the next video.